All right, we are live. Good morning, good morning, good morning. Do you hear me? Is there anybody out there? All right. So sorry about the delay. I was just held up in a meeting, but I think that gave you a decent opportunity to look over the solutions to the review sheet. Were you able to access that? That's number one. good morning, ladies. Leanna and Sarah. As usual, we got to check to see if this whiteboard is working. I'm trying to see. Here we go. All right. We have a word up. Let's see if the board is working. Please check. Good morning, Eleni. So I posted the word of the day on the board. I just need to make sure that it's working. And we're going to begin reviewing in about like a minute. Thank you. I say that because that's what I'm looking at. That's my view. I actually had a picture of my office setup that I wanted to share with everyone, but I didn't want that picture shared and then edited, and I don't know, you put me like on some ridiculous background or you distort my face. So I thought against it. But you could probably do that anyway with all the other media that's out there. Good morning, Brittany. All right, so you had a chance to look over the review sheet and the solution. So let's go. Shoot me a question. And while you shoot me a question, I'm going to have my Starbucks coffee. Backyard. That's right. I think this crew is too old for the Backyardigans, right? Isn't that like a kids show? I don't think you guys grew up with that, the Backyardigans. Or maybe you did, I don't know. Anyway, so I'm ready for your questions. I'm here. 36, page 2, down to business, Leanne. I like it. All right, so let's look at it. I'm just pulling it up. All right. So if I say page 2, number 36, yes, 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 this is a good question. This is a very good question. So if we look, all right, so make sure that you're there right now. So we'll look at all components, right? So let's look at the question. I just need to see the instructions. Let me pull up the original. Hold on, here we go. All right. So the original question says the following. Oh, yes, for each of the functions defined as follows. Find f of x plus h, and then b is f of x plus h minus f of x, and then lastly we have this fraction. So it seems intimidating. So we need to understand the others. So if we don't understand the others, then we cannot do the last piece. So if we look here, so what's the one asking? So here, if we have f of x, so the question is what is here? We're looking at 36, right? Let me managing 36. Okay, so 36 says this. Right? So hopefully the board is responsive. F of x, sorry, f of x is equal to 4x plus 11. So if we want to evaluate f of x plus h, right? So we know what f of x is. So here we have the following, 4x plus 11. So if we substitute that, right, we're going to have the following for a. So here, f of x plus h. So wherever we have x, we're going to make that f times x plus h plus 11. So I'm just zoom out. So that's going to be the approach. So here you have f of x, it equals to 4x plus 11. But if you're going to add h to the x component, this is how it's going to look like. And then obviously here, we would then distribute. So we have 4x plus 4h plus 11. So that should clarify A. So now if we look at the part B, right? So part B is essentially what we have up here, right? F of x plus h minus f of x. I believe that's what we have. Let's see if there's any comments right now. Okay, no comments so far. There are a few of you here today. Okay. So if we substitute in, we already know what this is, right? We know what this is. This was 4x plus 4h plus 11, because that we did in the previous part. But what is f of x? F of x is 4x minus 11. But this is where we need to be careful, because we're going to substitute all of f of x into this parentheses. So it becomes 4x plus 11. But when we distribute the negative, then it becomes as follows. So 4x plus 4h plus 11 minus 4x minus 11. So when we combine like terms, so I'll highlight them if they weren't obvious. We have the negative 4x and the positive 4x. We have the positive 4h by itself. And then here we have the 11s that are left over. So clearly the reds and the browns will cancel out, and you're left with this as a final answer for H. So before I move on to the next one, do we have any questions? Any questions so far? So just so you know, because there is a little bit of a lag in this communication, there is a chat box within the whiteboard. So if it's easier for you to, ask away as I'm doing it on the whiteboard, feel free. It's just that when I look at the chat within YouTube, it's a little delayed. So that's all. All right, so I'm guessing we're clear. So now the last piece, if we think about it now, it's f of x plus h minus f of x. All of this divided by h. So what I'm going to highlight now, this we already did. We did all of that. It's in the previous section. So, I could substitute everything there, or I could rewrite what we have. I'll rewrite it just so that you have continuity. So we know that f of x plus h, that was what? 4x plus 4h plus 11. Minus f of x was minus 4x minus 11. And now all of this will be divided by h. So we know that this will cancel or eliminate because we already did it in the previous section. So 4x and the minus 4x are gone. That becomes 0. Here, 11s with 11s are gone. So you're essentially left with this. 4h divided by h. So if you simplify that, you're just left with 4. Final answer. Was that clear, Leanna? I love reading these comments. Awesome. 61 now, page 2. All right, I will go to that question, but I want to see if there's anyone else that's out there that wants to look at a particular question. So as you look, let's see. I'm looking at your songs of the day. Seems like Party Next Door is kind of popular. Never heard of it, honestly. I don't know. Am I like living in a hole? Am I like completely out of it? La Bamba, that one I like. Para bailar la bamba. Let's see, anyone else? Anyone else? So right now we'll be looking at 61 on page 2. If I don't have any other volunteers, then that's the one that we'll be looking at. I hope that the solutions were clear. That's number 1. So whatever, you did see them, right? Is there anyone there that saw the solutions? I need to make sure that you saw it. You know, I don't want to assume, but they were posted, although they were posted a little bit late. Good morning, Josh. Yeah, I was actually up late last night. Um, I guess like a random story. Some guy, um, he wanted me to lay down a guitar track, like over some hip hop beat. Like I'm not even kidding you. So like I had to come up with a hip hop bass line, which is completely out of my comfort zone, and it was groovy. It was really groovy, and I was just like playing this loop for a minute. No. Playing this one like 10-second loop for like an hour, just hearing it back and forth and just trying to lay down some guitar. So anyway, so I was up late, so that's why I posted that late. Did you see the review sheet? I need to make sure that you saw it, that it's there, that it's live. Can someone confirm? Okay, so again, my question. Did you see the solutions to the review sheet? They are posted in the exam 2 materials. I need to make sure that you all have access to that. I just need one person to confirm. Anyone out there? It's really important that I have that confirmation. I need to make sure that you saw the solutions to the review sheet. I'll just double check now. It's in the classwork section, exam 2, review materials. If you click that, there are 2 files. One should say solutions. The other one is just the actual review sheet. Do you have access to it? The file is too large to preview. Are you getting those error messages? You saw this, okay, you see it, so it's good, it's working. Okay, good, all right. Now, let's go to number 61 on page 2. I'm looking at that right now. Okay, so good. Where is 61? Okay. All right, so what is this asking? So, given functions f and g, find a, f following g of x and its domain, and then g following f of x and its domain. So, if we look at 61, here we have f of x, right? So here, the first one, f following g of x. So the question is, which do we do first, right? So that's going to be number 1. So the way to rewrite this, don't forget, If you don't like that symbol, it will be f, and then you can put in parentheses g of x. So now the question is, what is g of x, right? So in this case, we have, this is 61, we have x squared plus 3x minus 1. So if we throw that in, so we basically have here f, right? And what's g of x? G of x then would be x squared minus 3, or sorry, plus 3x minus 1. But then we have to evaluate that. So the question is, what's f of x? So if we look, I mean, it would be somewhat taxing or daunting, but this entire thing would then simplify to the following. I mean, that's going to be a lot of work. I mean, could you do it? Of course, but just for our discussion, I will consider this mathematically acceptable because it is. It's just, you know, the workings or the interchanging between f following g of x and how that's simplified. So now the question is, what does this domain look like, right? What is the domain? So if you graph this, I would take a moment to graph it so that you could see. Again, I would use Desmos. Now, I wonder if I could throw in images here. So hold on. So I would go to Desmos right now, desmos.com, and then throw this in there. So I'm going to do that. I'm going to try to share the screen at some point. So this becomes x squared plus 3x minus 1. If not, then I'm just going to sketch the graph so you can see this. Oh boy. This thing looks crazy. It's okay. All right. All right. So if we're looking at the same thing, this is what's going to happen. And it's only asking for the domain, I believe. Right? So let me just look here. This is asking us, yes, and the domain. All right. So I'm going to sketch this graph quickly. And per what I'm looking at, this appears as follows. So you have your xy axis. So again, this is really loosely drawn. This is just a sketch. It's going to look terrible. So it's something like this. I apologize. But if you pulled up, or if you went to desmos.com, you put in this function here, the one that I'm circling. So again, this x squared plus 3x minus 1. I'll circle it in, I don't know, black. So what I'm circling in black, that I put into Desmos. So this is in Desmos. It's just a sketch. But what I care about is the domain, right? So if we look at this, the domain is infinite. It's infinite on the negative end and then on the positive end. So our domain would be, we're going from negative infinity to positive infinity. Is that helpful, Leanna? Any other questions? Did you want me to continue? Did you want to do also the reverse? G of f of x, we could do that also. And if you'd like, why not? This way we're comfortable. I don't want to, have you still confused. So G following f, and this is of x. So don't forget, if you don't like that, the presentation, you could always think of it this way. First, in parentheses, f of x, and what is f of x in this case? X cubed, so G of x cubed. But then when we substitute x cubed into G of x, it becomes the following. So it becomes x cubed raised to the power of 2 plus 3 times x cubed, and then this becomes what? Minus 1. So that's the simplification of this. And if we simplify that, it'll become x not to the 5th power, but to the 6th power plus 3x cubed minus 1. So now again, the question is, what does the domain look like? So you can sketch that on Desmos, but just to save a little bit of time, it will look somewhat related to what we did, maybe a little bit more odd, but the domain will stay the same. 45, page 4. Okay. Is there anyone else aside from Liana? There's nothing wrong with what Liana is asking, or even the amount of times that Liana is asking the question. I have no problem with that. I just want to make sure, though, that others get an opportunity, unless Liana is speaking on behalf of the class, and you guys are having a side chat, and everyone is telling Liana, "Hey, Liana, ask this question." No side chats allowed. Anyone else? Okay, can we go over page 3, question 24? All right, let's look at that, and then we'll go back to Liana's question. Okay, so page 3, question 24. Okay, so what we need to do, express f of x in the form f of x is equal to x minus k times q of x plus the remainder, right? So we have this. Aha. So we have 2 raised to the power, or 2x to the 4th power, right? This is a 24, making sure. Yep. Page 3. Plus x cubed minus 15x squared plus 3x. But I'm going to add plus 0 here because there is no constant, right? And our k value here is negative 3, right? So then when we divide, right? So that's the whole thing. So when you're dividing these polynomials, it's not difficult. It is difficult, but it's typically expressed as some polynomial of x divided by x minus k, if you remember our conversation. So sorry about the sloppiness, but that's what it was. And in this case, our k value is negative 3. So it's going to become this polynomial of x. All of that will be divided by x minus a negative 3, or x plus 3. So the polynomial of x divided by x plus 3. So what we need to do is we need to figure out what the quotient is. So we're going to apply the synthetic division. So let me rewrite here. So we have 2x to the 4th plus x cubed minus 15x squared plus 3x plus 0. So we're going to put all of the coefficients, don't forget, right? We're going to put that inside here. So we have 2, we have 1, we have negative 15, we have positive 3, and then we have 0. And outside will go our positive 3, and we will begin the synthetic division. So hopefully this is coming back to you. So now the question is this. So what do we need to do first? So if you remember, we have to bring this down, right? So it becomes 2. But then we're going to continue to multiply this, right? So when we bring this down, this is the multiplication. It becomes 3 times 2 or 6, but then we keep adding, right? So let me just look back here. So then when we have the following, what are we left with here? So when we continue along, right? So when we combine, we should be left with what here? We have 7. And then continuing along, what we have 3, then we multiply this with 21. And then when this combines, then we have here what, a positive 6. And then when we combine this is 18, what this becomes 21. And then when we continue this, what this becomes 66. So just take a moment to process all of that. I know it's a lot. Or what is the issue here? There's actually an issue. So the question is this. So I want to see if we spotted it. Is there feedback in the channel? No. Okay. So this is where we need to be careful. So if you look here, we started here with the positive 3, right? But the question is this. Does that or is that value correct? So I was hoping that someone would stop me here. That's why I kind of took a little bit of a pause. So let me go back. So I'm going to erase this. So everything here, the first part was fine, but remember the K value. So if the K value here is negative, yes, it becomes positive when you're dividing, but really the K value should be negative 3. This should have been negative 3. So that when you multiply, then you have negative 6. And then this becomes negative 5 or positive 15. This is 0. This becomes negative 3. And then this is 0 here. Or excuse me, this is 0. And then this becomes 3. And then we have here a negative 9, or we just bring that down. So this is what we needed to do. So that's why this may have been confusing, just because k equal to negative 3. Although it was positive in the denominator, we have to make that adjustment immediately with the divisor. So when we rewrite this, right, it becomes as follows. 2x cubed minus 5x squared. Since this is 0, right, we're not going to express it. So you could say that it's plus 0x. Just for continuity, then it becomes plus 3, and then minus 9 divided by x plus 3. So that would be a final answer, but the question is not asking you to express it. The question is not asking you to express it in this manner. It's asking you to express it in, it looks like a weird form, but it's really not. I'm going to go till 10 o'clock today, just FYI. So this way we have a little more time. I mean, you're free to leave now if you'd like, but I'll be here until 10. So I'm just going back to the instructions because it said for us to express this in the following form. F of x equals to x minus k times the quotient of x plus the remainder. So, a few things here. We know what f of x is. We know what f of x is. That's what's given. But x minus k is what we started with, x plus 3. The quotient of x, if I go back here, is this. This is the quotient. What I'm going to highlight in yellow, this is the quotient of x. So I'm going to rewrite that as, what did we have? 2x cubed. I'm going to ignore the 0 here. Minus 5x squared plus 3. And we need to add the remainder in. So when we go back, our remainder is what I'm circling here in green. This is the remainder. So that's going to go here, and I'm going to include it as the final solution. So what I'm going to now highlight in blue, what I'm highlighting in blue is the final answer. Is that clear, Sarah? I know that one was a little more complicated because we know how to do the synthetic division. So again, you just have to be careful when k is negative or positive. Please take that into consideration. Also, again, also something to consider is how you're expressing the answer. Right, so in this case, they want you to express it in kind of a unique form. X minus k times the quotient of x plus the remainder. Great, Sarah. All right, so since we have a new question, we'll go to Kyle and then Leanna. Sorry, Leanna. Only because you got 2 questions already. And we'll hit that one and then we'll go to yours. So page 6. So the last page, 28 or 29. Okay. So it's saying use the properties of logarithms to rewrite each expression. Simplify the result if possible. Assume all variables represent positive numbers. All right, so we have to go to our rules of logarithms here. So let's look. So I can tell you now that number 29, it cannot be simplified. So that was kind of a trick question. But 28 we can look at. So 28 we will look at. So let's see what we can do here. So we have log base 5. And then we have here what? X squared, right? Times y to the 4th. And then here I'm going to rewrite the following. I'm going to rewrite this as m cubed times p, but all of this here is going to be raised to the power of 1/5. So we're going to start there first. Right? And if you remember here with the rules of logarithms, right, we're multiplying, so we're going to detach this. And we're going to add them individually. So again, this becomes log base 5. Again, this is the product rule. X squared plus log base 5 of y to the 4th plus log base 5 of m cubed times p, all that raised to the power of 1/5. So let's apply the power rules here, or the product. No, this is the power rule, excuse me. So I'm going to highlight the powers in purple. So I'm just focusing on the powers for each. right? And I'm going to bring them to the front of the logarithm, and now they'll become factors. So if you remember, that should be the first step. So I'm going to rewrite all of this now. Sorry. So rewriting, this is going to become 2 times log base 5 of x. So there we're done with that. Plus 4 log base 5 of y, and plus, so now 1/5. This is the one that's the most difficult one. So I'm gonna spend more time on this one. So this is gonna become 1/5 of log base 5 of m cubed times p. But I'm going to rewrite this now because now I'm focusing on what's happening in the parentheses. So I'm going to I'm going to rewrite this with the product rule as, so this becomes plus 1/5 all of this now. And again, don't forget that you have your individual power here, right? So this is going to become, kind of taking a shortcut here just to save time, 3 log base 5 plus, what do we have here? Log base 5 of p. So that's the whole thing in a nutshell. So I'll rewrite it as a single or with all of these logarithms. So log base 5 of x, or 2 log base 5 of x, excuse me. I'm like running out of room. Just too much logs right now. 2 log base 5 of x plus 4 log base 5 of y, and then everything else. Okay. Kyle, is that clear? All right, great. So a question like number 45 on page 4, let's look here. Okay. Okay, so with this, so we could do this. We certainly can. I don't believe that I will focus on this on the exam. So that would be number 1. So remember, if you want to, I'll do it quickly just so that you understand the question, but it's not going to be a focus of the exam, right? So the zeros. So we're basically solving these binomials for 0. So to begin, you'd have to divide 3 out of this. So that's number 1. So 3 is gone. 0 divided by 3 is just 3. So we're left with 0 is equal to x minus 2 times x plus 3. And then this becomes times x squared minus 1. So we set these individual binomials equal to 0, and we solve. And if we solve correctly, x equals 2, x equals negative 3. And now this is where this becomes a little bit interesting, x squared, because when it equals to 1, and we take the square root of both sides, it's plus or minus 1. So that should be the solutions for number 45. Any other questions for me? We have about 5 more minutes left. Any questions before we wrap up? So again, the format of the exam. So just to reiterate that, the exam will be given. It's going to be given again on Friday. 44, page 5. So the question is, are these inverses, right? So that's the question. Let's see. Just give me 1 second. You said 44, page 5. So how to determine if you have inverses? I mean, you could graph both of them. The easy way to do it would be the following. So with the tools at your disposal, if you use Desmos and you plug both of these equations in, I wish I could share my screen with you right now. That's one of the challenges. Again, I don't want to reiterate what I've already mentioned in the past. So if you go to Desmos and you put these equations in, both of them, instead of f of x, you put y equals, right? And if they do not have symmetry along the line y equals x, so you would be plotting 3 equations. The f of x, is there a g of x that's given there? Let me just double check. Hold on. Yeah, so 44, page 5, right. So basically, you put f of x and then g of x. You put both of those into Desmos, graph them, and then you plot the line y equals x. So this is what you're doing. So basically, you would do something like this. So this, if you're in Desmos, you plug in f of x, you plug in g of x, and then the most important one is y equals x. So that when you graph, so I'm on the whiteboard showing this. So when you graph this, if you notice symmetry along this blue line is y equals x. So if those lines or these graphs that you produce, if they're symmetrical about this line, then you have inverses. Now some of you may be saying, I don't like Desmos, or I want to know how to do this by hand. So instead of f of x, we'll call it y. And so y, I'll do one of them. I'll do it quickly. So 44. So to test, f of x equals negative 4x plus 2. Negative 4x plus 2. Inverses x becomes y becomes x, and now we solve for our new y. So we subtract 2, so it becomes x minus 2 is equal to negative 4y. But when you divide this, we have here, again, dividing negative 4 to both sides, we're left with the following. Negative 1/4 x, right, plus half will equal to y. And that is not g of x. So they are not inverses. So this y, this does not equal to the g of x. If they were equal, then they would be inverses. So going back to, let's see, 1 second. Okay. All right, so how are we going to take the exam? So this is what's going to happen. I will share something Friday morning. So the exam will be between 8 and 10 a.m. 8 and 10 a.m. You're going to do this on a separate sheet of paper. So again, it'll probably be between 5 and 10 short answer questions. I'm leaning on you picking at the very least 5, maybe 6. You have 2 hours to answer that. You take a picture of the work, put it all together in how you've been submitting work in Google Classroom, and then that is your exam. And then I'll grade it. You have 2 hours though. That's it, 2 hours. So now the question is this: what happens if you submit it after 10 o'clock, right? So the way that I am designing this exam, the way that this exam is designed, if I were you, I would do this. Like if you're really like paranoid, I guess you could take a picture once you're done with one question, take a picture and submit it. So then it's in. Don't try to submit all the questions in one shot. Make sure that your work is clear, that there's no blurriness. Take the picture, submit it, and then that will be your response for one of the questions. And then you do that an additional 4 times, so then you'll have 5 questions submitted. I think the way that I'm going to design the exam, it should not take you more than an hour. 2 hours is overkill. I just want you to know that 2 hours is overkill, but things happen in the morning. I don't know. Like I can think of all of the things that could go wrong. So in thinking about that, right? I think 2 hours. When you see the exam, you'll be really, really happy. You'll be thanking me immensely. It's not meant to be punitive. It's meant to be understanding of your situation. I totally get it. I'm trying to be very flexible. And again, when you see it, you'll be happy. Take the picture, submit the work, and that's it. However, I warn you, I would not work with each other. There's going to be that temptation. Do not do that. Not only is it dishonest, if I catch you cheating here, now remember, it will be very simple to catch cheating, right? So think about it. Think about how simple it is in this setting. There's pictures that you're submitting. Right, then you're going to say, but what if the workflow is the same? I mean, it could be, but more often than not, students have a unique way of showing their work, right? So if you're copying, that will be evident, that will be very clear, and I will be less, flexible. I will be less flexible with academic dishonesty on this exam. It's not meant to be punitive. Again, it's meant to help you. So now something also to think about. If you're at home, and given that AP exams are going to be given at home, there's some flexibility. So I just want you to think about that, right? You're at home, you have 2 hours to complete about 5 questions. I'm not monitoring what you're doing in your room. You have access to resources. I mean, everything is in your favor to do well on this exam. I'll leave it at that. In the past, you've asked me, is there going to be a formula sheet? You are no longer in a classroom where I need to provide that for you. I hope you're kind of reading between the lines here as to the resources that you have at your disposal to do the best that you can on this exam. Are there any questions here or any final thoughts, etc.? Because if there's no final thoughts, again, you have all the solutions. They're pretty detailed, some questions, and I'll try to keep it to the questions that we spoke about today. And if there's detailed work that has been provided or solutions step by step, I'll try to stick to those questions as well. There are not going to be any like curveballs here. I'm going to play fair, and I want you guys to do well. Any questions before we wrap up? Okay, so if there are no further questions, that's it. Please study. Again, the questions will be posted 8 a.m. I may even be kinder and post it earlier, but the cutoff will be 10 a.m. The cutoff will be 10 a.m. So I urge you, picture, post. Continue next question. Picture, post. Then next question. Picture, post. I think that would be the easiest way to go about this. Plenty of time, like I said, overkill, 2 hours. Some of you may be done in a half hour. I'm just letting you know that it's going to be quite flexible and it will be in your favor to do, or how it's designed, it's going to be in your favor. So that's it. Have a great day. Enjoy the rest of the week. If you have any questions, please message me. I'll be around, and I'll see you on Friday morning. No excuses, no buses to take, right? No trains to catch. I'll see you later.